Okay, student, good afternoon, everyone. So, am I audible to everyone? Right?
Yes.
Yes, sir,
Sir,
you're audible.
Yes. Okay. So, I'm just focusing on the whiteboard. Is it visible to everyone, right?
yes, sir.
Yes, sir.
Okay, fine. So, as we already discussed in our last week class, we already started the discussion about the number system.
Yes, a compliment we will do.
Yes, I already discussed about the various kind of number system, their conversions, and one's complement, two's complement. I have already discussed and show you with the help of some examples. Now, today, one topic we have left due to a shortage of time, that how we can perform a subtraction between two numbers using second complement. Actually, lots of people are asking, or lots of students are asking a very common question. They said, why we are learning about the second complement or one is complement or two complement? What is the necessity of learning this thing? Right. The necessity is that in 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 mathematical scenario we can perform addition by the help of an addition operator, like 7 plus 4 equal to 11, right? We can perform subtraction with the help of same mathematical operations, subtraction operation, that is 7 minus 4 equal to 3. So this kind of operation we can perform in mathematics, okay, with the help of a direct use of the arithmetic operation. Okay, these are called arithmetic operator or binary arithmetic operator, which require at least two decimal numbers to perform these operations, right? But the thing is that in practice, when a computer system implement all these operations in the form of hardware, actually computer memory, processor, all actually built with a various kind of hardware IC chips, right? As we know that our fifth generation computers are generally suitable for this kind of IC chips, VLSI, ULSI. I already discussed about it. Very large scale integration, ultra large scale integration. So our fifth generation of computers are generally consist of with this powerful IC circuits or IC chips are called VLSI and ULSI. So these IC circuits are generally embedded with several kind of digital circuits. As for example, adder, binary adder, which is more specifically called binary adder. Okay. In the same way, there is some other concept like binary subtractor. Sorry, binary subtractor, which perform subtraction operation. And these binary adder, binary subtractor, all are hardware. All are hardware. Those are not software. Those are embedded as a part of the chip of IC chip of VLSI or ULSI, like this, right? So in practice, there are some parallel binary adder chip are available into the market. Okay, with the help of some IC numbers are there. Some IC numbers are there. Like chips are generally started 7483. This is the IC number where the binary adder entered IC has been embedded. Okay, you can purchase this IC chip from the market, from anywhere where the retail IC chips are available. You can purchase this chip, and after purchasing this chip, you are able to perform 4-bit parallel, 4-bit parallel binary addition operation. Binary addition operation. So that's why this circuit is called 4-bit parallel binary adder circuit. Right? Up to this clear? Anyone has any question? These are very common, and you will definitely use this IC chip in your future labs of computer organization and data electronics. You will definitely use this use this IC chip, okay, to build a circuit, a bigger circuit. So these IC chips are available into a market where the internal binary adder circuit has been embedded or implemented, right? But the problem is that no IC chips is available. No IC chip are available or is available to perform the subtraction operation, these operations. That means there is no 4-bit parallel binary subtractor IC chip available in the market. You will only have this binary adder circuit chip, okay, or addition circuit chip. Now the question is that then how can we perform a binary subtraction within a computer system with the help of this adder chip? That is the question. That means we have to perform binary addition, but in somehow that we can use only this adder chip. So obviously in practice now you are thinking that how it is possible, because this chip will perform addition, and how can we perform binary subtraction with the help of addition? We can perform binary subtraction with the help of addition by using the concept of second-s complement. Up to this clear? Is it clear to everyone? Why we are using second-s complement? Up to this, everyone clear?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
This concept is very important. Everyone try to understand. Okay. So suppose I am performing, so addition operation will not create any problem. The problem is there regarding this subtraction operation, right? So suppose I am performing this subtraction, 7 minus 4 equal to 3. Now how can I perform this subtraction with the help of addition operation? Why? Why we are using addition operation to perform this subtraction? Because we only have this adder chip in the market, and somehow we have to implement this subtraction operation with the help of the addition operation. Okay. So how can I implement it? Let's check it out and try to understand. So this is the given example to you. Now our first job is to convert this 7 into its corresponding binary numbers. Now if it is a 4-bit parallel binary adder, because this IC chip 7483 I already told it is a 4-bit parallel binary adder, so each and every bit will be converted into its corresponding 4-bit. Okay, each and every number which is participated into the operation will be converted into corresponding 4-bit. Suppose we will assume it as a 4-bit system, right? So 7 will be converted into corresponding 4-bit. So can anyone tell me what is the binary representation of a 7? 1, 1, 1, right? So if we will convert this 7 into its corresponding 4-bit, where we should add 0, right hand side or left hand side? Where we should add an extra 0?
Left hand side we have to add 0. 0, 1, 1, 1.
Yes.
Left hand side.
Yes.
Left hand side.
0, 1, 1, 1. That is our objective, right? Now in the same way, we will convert, our second number is 4. So we will convert this 4
0, 100. 0, 1, 0, 0.
0, 1, 0, 0. Very good.
0, 0, yes.
Now, what we will do? Now our second job. This is the first job. Okay, first, what is the first job? Simple. Simple. The step one tells that we have to first convert.
Hello.
Hello. Yes.
Yes.
Yes, I'm repeating.
Sir, can you again tell us that?
Yes. I'm repeating.
Yeah.
So our first job is
No,
to
I'm saying that
yes.
left side.
Okay, good. That extra 0. In
Left side of you put 0.
In last class, I already discussed about it, about the extra padding 0. Have you present in the last class?
Yes, sir. Maybe at that time my network was slow, so I can't.
So 0 actually will be added at the left hand side, because after adding 0 at the left hand side, the total weightage of this number will not be changed. If we somehow add extra 0 at the right hand side, then it is entirely wrong, because the weightage of the entire number will be changed. Okay, drastically changed. So
okay, sir. Got it.
Don't want it, because we should stick with our weightage, given weightage we have. That's why we have added extra 0 at the left hand side, right? So this is the step number 1, that we have to convert these decimal numbers into its corresponding binary number. This is step number 1. Remember it. Step number 2, we have to apply the second-s complement on the second number. That means this one. We have to apply the second-s complement on the added number. This is the adder and this is the added bit. Okay. So we have to convert we have to apply second-s complement on the second number. This one. What was the second-s complement? Last time I told, to apply the second-s complement, we have to first convert this number, these binary numbers, into its corresponding 1's complement. 1's complement means 0 becomes 1 and 1 becomes 0. So 1, 0, 1, 1. Right? And then we have to add, perform a binary addition with an extra 1 plus 1 with this number. So if you perform binary addition, then 1 plus 1, 0. If you remember the table which I already draw in the last class,
1 double 0.
1 plus 1, 0. There is a carry 1, right? That carry will be added with the next one. That means 1 plus 1, again 0. Again carry 1. That carry will be added with the next bit, that is 0. 1 plus 0, 1. No carry. No carry means 0 carry. Carry is 0. And that 0 will be added with the next one, that is 1. So this is the second complement of the second number. So our second step is to perform 2's complement or second complement on the second number, right? Everyone clear? This is step 2. Up to this, anyone has any question? Is it clear to everyone?
Yes, sir, clear. It's clear.
Now,
স্যার যোগটা কি করে করলেন ঠিক বুঝলাম না।
binary addition. In last class, I already told about the addition 0, 0, 0, 0. So A, B, this is sum and this is carry. Okay, 0, 0. If this is 0, 0, the sum is 0, carry is 0. If this is 0, 1, sum is 1, carry is 0. If this is 1, 0, sum is 1, carry is 0. If this is 1, 1, means these are the input numbers, these are the outputs. So 1, 1 means sum is 0, carry is 1. Carry means যেটা আমরা যোগ করার সময় we actually taking that number in our hand, that is called carry here. Okay, so here we have to add the numbers 1 with the first one. So 1 plus 1 means which one? This one. So what is the sum? Sum is 0, so sum is 0. What was the carry? Carry is 1, so 1 is there, and that carry will be added with the next bit. Then again 1 plus 1, 0, carry 1, and that carry will be added with the next bit. Then 1 plus 0, 1 plus 0 means this one. So sum is 1, carry is 0. So that's why sum 1, carry is 0, and that carry will be added with the next bit. That means 0 plus 1. So again sum is 1, carry is 0. So 1 will be put in, no carry is there. Carry is 0, that 0 means no carry. Okay. Is it clear? This is a binary addition truth table that I already showed and discussed in the last class. Okay. Is it clear to everyone? Is it clear,
Yes,
right?
sir.
Okay. So our next job, step number 3. Step number 3 is to add the resultant number, that means the output number, what we have received the output after applying second complement in the second number. Resultant number will be added with the first number. What is the result number? This one, 1100. What was the first number? It is 0111. Simply we will perform binary addition with the resultant number and the first number. So our first number is 0111 and our resultant number is 1100. Resultant means after applying second complement of the second number, this is the resultant number. Okay, and we will perform simple binary addition. Binary addition means which one? This one. Again we will do, and we will perform the addition bit by bit parallel. Okay, so 1 plus 0, 1. 1 plus 0, sum is 1, carry is 0. So carry is 0. Okay, that means no carry. So you can add this 0 with this number as your choice. Actually, we should add the carry with the lower bits. Okay. So 0 plus 0 means 0, and that 0 plus 1 means again 1, no carry. So 1 plus 1 means 0. Here 1 carry will be generated, right? Because 1 plus 1 0, and there is 1 carry 1. So 1 carry is generated, and that carry will be added with the next number. So 1 plus 1 again 0, and that 0 will be added with this 0. Okay, 1 plus 1 0, sum is 0, and the sum will be added with this 0. So 0 plus 0 finally 0, but there is one more carry, and our main job is to neglect this carry. Remember it. Our main job is to neglect this carry. If there is no carry, then we have no problem. Then there is no question of neglecting a carry. But if somehow the carry will be generated here, it may be generated, and we have to neglect this carry. And the result that we have.
There will be 0.
Yes.
No, sir.
Yes.
If there will be 0, then the number will be 11. I mean 11.
Yes. That will be 0011. And what is the decimal representation of this 0011? What is the decimal representation of this 0011? 3. So we will match
3
with the results. Okay. Is it clear? বুঝতে পারলে? Is it clear? Up to this is clear how I can calculate the subtraction with the help of second complement. Is it clear? Right.
Yes, sir.
So here in these whole operations, have I applied any kind of subtraction operation, binary subtraction? In this whole operation, have I applied any kind of binary subtraction? No, I have applied
No,
only
sir.
binary
No,
addition.
it's only addition and
Yes, this is addition. This is also addition. So I have applied only binary addition. So we can perform all these operations with the help of the IC 7483, which is nothing but a binary parallel adder. So we can successfully perform all these operations with the help of this IC. But actually at the back end, we actually performing what? Subtraction operation. Clear? Is it clear? It's very important. This question is very important. In your exam, you will get
Yes,
some
sir.
question and you will have to prove why we use second complement, and then they can give any example and they will ask you to perform a subtraction operation with the help of second complement, and then you have to show in this way. And the step which I am stating in front of you with the help of my own
Sir,
word, you have to
শেষের
write those.
ক্যারিটা ধরবো না?
Nah, the next carry will not be considered. Neglect carry. That's why I am writing neglect carry. Okay, neglecting the carry.
Okay, sir.
If zero carry will be generated, then there is no question of taking that carry because zero has no value. If one carry will be generated, then we have to neglect it, and that is mandatory. This is the last step of this entire process. And the steps which I actually explained in my own words, you have to write all these steps at the time of examination when they will give this question. If they will give the example, don't do in this way. Okay, write step by step. First, step 1, that convert the decimal number into its corresponding binary bits. Step 2, that apply second complement in the second bit of the addition, then perform second complement. Then step 3, add the resultant output with the first binary representation of the first digit. Okay, and then step 4, regarding the carry. If any carry will be generated, we should neglect it and then convert the final output, binary output, into its corresponding decimal number. That will be our binary subtraction. Clear? Everyone clear? Okay. Okay.
স্যার যদি ওটা প্রথমে জিরোর জায়গায় যদি 1 থাকতো ওটা?
Which one? 0 জায়গায় 1 থাকলে which one?
Hello?
Which one?
হ্যাঁ হ্যাঁ ওটাই ওটাই। আপনি এটা দেখাচ্ছেন
এটা
0111 না, যেটা 0111 আছে, জিরোর জায়গায় যদি ওটা 1 থাকতো ওপরে, সবথেকে
এখানে
উপরে। হ্যাঁ,
তো
এটা
এটা তো সাথে রিপ্রেজেন্টেশন, 0 জায়গায়
হ্যাঁ
1 কেন
হ্যাঁ
থাকবে? আচ্ছা 1 যদি থাকতো, আচ্ছা আচ্ছা, ইফ ইউ অ্যাজিউম, নো প্রবলেম। তো ইফ
হ্যাঁ
0 এর জায়গায় যদি 1 থাকতো, তাহলে এটা 1 করলে এর কি হবে বলো? এর বাইনারিটা কি হবে বলো? চারটে 1 যদি হয় তাহলে কত হবে বলো? 16 2 to 0 1 to square by cube 16,
16।
right? 16. So 16 minus 4 means what? 12. 16 minus 4 means 12. So we'll check it. 1 1 1 plus 1 0, carry 1, that 1 plus 1 0, 0 plus 1, this should be 1, and again carry 1, and that carry will be neglected.
স্যার যাই থাকুক না কেন আমাদেরকে ক্যারিটা নেগলেক্ট করতে হবে।
Exactly. আমি সেটাই বারবার বলছি, whatever the number, carry should be neglected. Now convert this decimal into corresponding binary. Convert this binary into corresponding decimal. 2 by 0, 2 by 1, 2 by square, 2 by cube. So 8 plus 3 plus 1, that is 12. Clear? Clear? বুঝতে পারলে? Is it
Yes, sir.
clear?
Okay, sir.
You have to
Yes,
practice
sir.
it, okay? You have to practice it at your home, please. Okay, so this is all about the number system. Now we should start with a new discussion about the C programming language, the basics of C programming language. The basics of C programming language that you are waiting to start, okay? C language. Okay. So very basic concept about C language, that C has been was developed by Carnahan and Dennis Ritchie. Okay, his full name I didn't remember. Carnahan and Dennis Ritchie. Spelling may be wrong. Okay, Dennis Ritchie. These are the two pioneer scientists or mathematicians who developed the C programming language around in the year of 1970s. Right, around in the year of 1970s. And at that time, the C is called KNRC. Okay, the name of that language they have given, they gave as KNRC. K means Carnahan and K, and R means Dennis Ritchie R. Okay, Ritchie R. KNRC. Okay, after 10 years, around 1980, it has been standardized or accepted by ANSI, American National Standard Institute. Okay, and then it becomes NCC. Okay, and then it becomes commercially flourished. At that time, it becomes commercially flourished or commercially used in the market for the programming, software programming, or to build up various kind of software. Okay. Now, this Carnahan and Dennis Ritchie, they're actually working in Bell Laboratories, in Bell AT&T Bell Laboratories, AT&T Bell Laboratories. It actually situated in London, UK. Okay, AT&T Bell Laboratory. Okay, and they actually working on a project to build a special kind of operating system, which is called Unix. They actually working in that project. Okay, at that time Unix was the first operating system which was trying to develop, which should be a multi-user and multitasking, and whose security is very should be very powerful. And such kind of operating system are trying to build by these two persons at that time in AT&T Bell Laboratory. While they are building this Unix laboratory, during the same time, they failed to develop a new kind of programming language, which was helped to build such kind of OS and makes the operating system so much powerful. And to implement or to build this operating system, they actually introduce or they actually develop this C programming language. So that's why 70% code of the Unix operating system, 70% code of the Unix operating system has been made with the help of C programming language.
In C.
C language. Okay, in Linux, Unix, whatever operating system you are using, 70% of its code is made up of C programming language. Okay, in future they have a very high fund application of C programming language. At that time, before the Java came, Java commercialized around 1995. Okay, Java commercialized around 1995. So in this 15 years, C was one of the most popular and more commercially used programming language. And at that time, several software or several kind of software programs has been developed. Software has been developed which actually built with the help of C programming language. Before C, there are some other language exist like Algol 68, Algol 68, then Ural. Okay, before C, then BCPL. Okay, and just before C, Fortran was there also there. Yes, right, Fortran was also there. But just before C, there was one language which was B. You know, number C right? Which was B. Just before C, the B was such a kind of language which is called the predecessor of C, or you can say C is such kind of language which is called successor of B programming language. B er aage bole Algol, Coral, BCPL, much before than B. And whatever language has been developed at that time in the market, it was not so popular or so powerful like C programming language. That's why those languages which was there before C was not commercially flourished into the market. Commercially খুব বেশি use হয়নি these languages because it has some sort of drawbacks, or you can say that it is was not, they were not so much powerful or popular like C programming language. Okay, why it is popular? It has some features that we are going to discuss one by one. That's why it's popular. Okay, so let's talk about the features of the C programming language. C programming language. C programming language. First features, you can say the features or characteristics of C programming language, which makes C programming language was one of the popular language. Okay, before Java came, and even till now, C has a separate sort of platform, or separate sort of weightage, or separate sort of prestige. It actually occupied till now. C, even Java was there, Python was there, every other language was there, but C has its separate role. Its separate role in its own uh, area, okay, or its own territory. So features of C, the first features of C, and please remember all these features are generally compatible good or compatible well in terms of the previous languages. C should not be compared with the successors, right? C programming language should not compare with the successors, because what are the successors of C language? Java, Python, JSP, all are C successor of C language. Obviously, successor means they actually occupy some of the special capabilities from C, okay, or C++. They have some of the special capability of C, okay. But obviously, we should not compare with that, because when C language was developed, it has been remembered that it should be compared well with its previous or predecessor languages like Algol, Coral, okay, Fortran, or BPCA, BCPL, B, all these languages. The first and most important features of C, easy to learn, easy to learn and understand, easy to learn and understand. Remember, before C, whatever language you are going to learn, okay, before C, whatever language was there in the market, most of the language are very much close to the assembly language. Assembly language. And I already discussed about the assembly language in my last couple of classes. What is the assembly language? How it will look like? If code আমি দেখিয়েছিলাম how we can write an assembly language, and what is the difference between assembly language and a high level language. Obviously, C is the high level language. Okay, so it is high level language. That's why it is mostly made of with the letters A to Z, or capital A to Z, or any numbers 0 to 9, or any kind of special symbols, okay, that we already have in our desktop or in our laptop. Okay, so all these symbols, numbers are very much familiar with the human being. That's why it's called a high level language, and it is easy to learn and easy to understand. Okay, here's the first feature of C. Second feature, which is the most important feature, very important feature, C programming language, that C was the first programming language which introduced the concept of modular programming, And this modular programming concept makes C was one of the most powerful language at that time. Okay, modular programming, or sometimes it is called structured programming. Any one of the term can be used simultaneously. Structured programming, or sometimes it is called procedural language. Procedural language. So if anyone will ask you, give me an example of a procedural language or a structured programming language, then you can easily use the term, use this language for representing. Now, after C, whatever language was there as a successor of C programming language like Java, JSP, Python, whatever language was introduced, C++, all follows this common.
Hello, sir.
Yes, please.
Hello.
বলো।
হ্যাঁ স্যার বলছি যে স্ট্রাকচারাল প্রসিডিউরাল ল্যাঙ্গুয়েজ আর অবজেক্ট ওরিয়েন্টেড ল্যাঙ্গুয়েজের মধ্যে ডিফারেন্স কি?
বলছি সেই ডিফারেন্সই আসছে। That is the major thing that we should learn. We should know.
আচ্ছা আচ্ছা।
Okay, so what is a modular programming language? And before C, whatever language was there in the market, BCPL, B, Coral, Algol, they didn't follow any kind of this modular programming approach. And that's why these languages was not commercially flourished, or was not used for making any kind of good commercial software. But after C language, whatever language came, Java, Python, all are follows this all these common features, including modular programming approach or structure programming approach. Now, obviously, from this name structure programming, you can understood that the program should be written in a structured format, well-structured manner, a well-structured format. Now, what do you mean the structured format? Let me give you one example, very simple example. Suppose, listen to the example very carefully. Okay. Suppose you are working in a company, you are a manager of a company, right? And under your managership, suppose there are two teams. Okay, developer teams or coder teams, you can say, who are doing codes. Okay, in C programming language, right? Two teams are there. The first team is is doing a code. Okay, so you have given what? You have given a small project. Okay, a small project to both the team members. Okay, both the team. Each and every team consists of 5 team members. Suppose 5 team members, and you have given both the same project to both the team members, right? Now, what is the basic approach that each team member should follow? What do you think? I want to know your if suppose you are the you are as a person of that team member, then what approach you will follow? Your team consists of 5 members. To complete the project, what approach you will follow? I want to know that answer from you. Tell me the answer.
Sir, সবাইকে কাজ ভাগ
Yes.
করে দাও।
Divide and conquer. One person has written as divide and conquer. সবাইকে কাজটা ভাগ করো. That is the very general issue, right? That the general approach that we need to follow. But at that time, when C was developed in 1970s, 1980s, because at that time the programming coding sense of the persons are very rare. Okay, very rare. At that time there was no concept of IT company outsourcing. All this concept was not there. You understood that thing. These are very early of the stage. Even our Pentium 1 machine was not there at that time. So at that time, what they actually do, instead of dividing the work into number of persons, there is one person, main person, who is the most best coder of that team. He will do the entire code, right? And that code has been checked by the other persons, or has been corrected by the other person. If there is any type of mistakes are there, if any type of problem is there, then other persons will check it or correct it. Okay. So the problem is that, what was the problem in that case, in that scenario? Suppose your code consists of, suppose, 1000 lines. Your code consists of, suppose, with the help of 1000 lines. Okay, 1000 line code, right? Now, when you have built an entire code and supply to the customer means provide code or supply code for the checking, right? Now, at the end phase, while you have already written all your code, the customer has given a complaint that a portion of that code needs to be changed. Okay, customer বলল না আমার পছন্দ হয়নি, you have to change a small portion of that code, and customer to don't understand. Customer is not a computer friendly, a programmer friendly, so he or she doesn't understand. He or she is telling by his own words that this code should be worked in this way. Okay, now the thing is that in this way means what? In which portion of this code that code needs to be modified, that we have to first identify. So there are 1000 lines. So what the job of the developer? They have to again check the code from the line number 1 to 2, 3, 4, 5, and suppose that needed changes has been done. The needed changes has been done at the line number, suppose 900. So the programmer will check the entire code and then reach at line number 900, and then he will do the modification of it. So obviously this entire process is very much time consuming and requires lots of effort to solve. Agree with me? I think all of you agree with me. So this process, instead of this process, this was actually obsolete process. We should not follow this process. But at that time, that process, before C programming language, all the programming languages are following this sort of approach or this sort of process. Okay, and C programming language, when it arrives, it makes a revolution. Okay, and instead of following this kind of process, it actually divides this 1000-line codes, into number of small modules. Suppose it will divide into number of 5 modules. First module contains 200 lines. Second module contains 200 lines. Third module contains 200 lines. Fourth module also 200 lines, and the last module contains 200. Okay, and they will assign individual person to handle that particular module. Suppose the first module has been handled by engineer 1, second module has been handled by engineer 2, third module has been handled by engineer 3, and so on. So if at the end of the code, if customer has make a question or make a complaint that the code needs to be changed, then the manager who actually handling the entire project, the manager will find out in who in which portion of the code has a mistake or has a needs to be changed, and he will inform that particular guy instead of touching the other code or other part. It will inform the particular guy whose set of modules need to be modified or need to be changed. So obviously the modification has been done only on this 200